I'm lecturer of the Department of Chemical and Environmental Engineering in the Engineering School at the Universidad Politécnica de Madrid. It's a big pleasure for me to be the chairman of this Sustainability and Life Cycle Assessment Roundtable. So thank you very much, Beatriz, and the other members of the organizing committee to give me this opportunity. First of all, I would like to give you some information about the organization of this table. There will be 3 different presentations. After each of them, we have time for some 2 or 3 quick questions for the corresponding speaker. During the session, all of you can write down questions or comments in the chat to be asked and discussed after the presentations, and we will have 1 hour or half an hour for talking about them with the speakers. So let's start introducing the first speaker, María José Amores Barrero. María José is a chemical engineer from the Higher Technical School of Chemical Engineering of the Rovira and Virgili University of Tarragona, where she obtained a master's degree in chemical and process engineering. She completed her PhD in chemical, environmental and environmental engineering processes and obtained a postgraduate degree in water business development from EADA Business School Barcelona and the Polytechnic University of Catalonia. Since 2013, she has continued her professional career in the sustainability, environmental, economic and social area of Agua, the Water Technology Center of the Agua Swat Group. She is head of projects based on the methodologies of life cycle assessment, water footprint, carbon footprint, and the urban and industrial water cycle. Recently, she is responsible for helping organizations to identify circular opportunities. She has carried out other tasks such as well-tool development and methodology certification processes. So, María José, thank you very much for being here with us, and the floor is yours.
Okay, thank you, Juan Manuel. I'm sharing my screen. Okay. Can you see my screen?
Yes.
Okay, perfect. So thank you very much to organizers of the second International Congress on Water and Sustainability. It's a pleasure for me to be here to present this work. This is regarding the to assessing the urban circularity, the development and application of a multi-scale circular economy model in regions. First of all, I would like to introduce about Agua for nobody knows about what is the Water Technology Center. The Water Technology Center is from Aguas de Barcelona and Suez. This is the Spain water technology. We have a public and private model of collaboration, and this is was created to ensure the sustainability and the efficiency of the water cycle. And we have 4 organizations, in local organizations, 3 in Spain and 1 other in Santiago de Chile. And the composition is about the local water company, the Polytechnic University in its case, and also the CSIC. We have 5 main areas. One of them is the water resources management regarding the water as a resource from the groundwater and the surface water to be the treatment from drinking water treatment processes. Also, another area is the biofactory and resources recovery to maximize the concept of the biofactory from the wastewater treatment plants towards the zero liquid discharge, the energy resources and green energy resources, and the valorizations of the wastes. Also, we have a critical infrastructure management and resilience, and including here the quality of the water, and 2 other transversal areas that is regarding the water 4.0, that is regarding the digitalization of the urban water processes, and my area that is regarding the environmental, economic, and social sustainability. We have also a brand to promote the circular economy at a national level, and our mission here is to accelerate the transition to to a circular economy model in the regions and organizations from 3 points of view, from water, energy, and waste resources, taking into account the governance and the management. This is sustainability partners. I put the correct address here to visit and to enjoy with you regarding the alignment of the circular economy concept with the Sustainable Development Goals. So my presentation today is structured in four steps. The first one, I would like to introduce you some concepts about the circular economy context regarding the water, energy, and waste, and then the second part is regarding some specific and successful case studies that we have done in the Barcelona metropolitan area regarding the application of the circular economy models, reducing the water and carbon footprint and promoting the life cycle assessment concept. And finally, I introduce you some techniques that we have applying in the urban water cycle. The first one, I would like to introduce the evolution of the circular economy and some measurement systems. In the top of the slide, you have this timeline regarding to the circular economy strategies in more general or more applicated in cities, from the Foundation Ellen MacArthur Foundation that was the pioneer in introducing this concept from evolution from the sustainability concept. In China, the development strategy of the circular economy in 2012. Then in the European plan action from 2015 and to 2020. Some other urban agendas for the European partnerships on circular economy, some local in national level in Spain about the strategy of circular economy, and some circular economy cities in the program of the Ellen MacArthur Foundation. And regarding indicators, there are several initiatives. We have done a very exhaustive setup about the other indicators that are worldwide regarding the circular economy indicators and tools from the Ellen MacArthur Foundation, from the China strategies, from the European monitoring frameworks, and other like the circular metrics to evaluate the cities in the context of the circular economy. So regarding the principles and strategies, I think that everyone is known, but I would like to refresh something about the eco-design that is very important in the eco-design in the products to avoid the design waste and pollution. Important also is all the procedure and the final management to valorize this waste and to introduce in the cascade to try to impulse the circularity in all the processes. So the three main topics is to design out waste and pollution, to try to optimize the amount of energy, minerals, and also the consumptive use of water, taking into account measured solutions, to keep products in materials in use. This is the idea to optimize the energy, the resource extraction, also the value generated in all the systems, including in the water systems and other that are in connection with the water systems, and to regenerate the natural systems. Okay, regarding the context of the water, energy, and waste, we have different circular challenges from the European Union impulsion. We need to promote water reuse as a safe and economic alternative to the wastewater flows. With also regarding energy, we need to promote green energy to promoting the reduction of the greenhouse gases emissions, and also to obtain the neutrality of climate. And regarding waste, we need to promote the 7 R's, the recycle, resources, restoration. So all different options of valorization to try to improve the recycling until 65% in 2035, and to have a limit of deposit the waste to landfill. So with this context, Agua has established a definition of a circular economy model processes in cities to promote, and not only for cities, but also for organizations to promote, to implement circular economy models taking into account three flows: water, energy, and waste assessment. First of all, when we start these kinds of studies, we first need to identify the different key actors that are in the regions. Also, we need to perform this flow analysis, taking into account different interviews, different workshops, to obtain and collect all the information regarding data, data from water balances, input and output, also the energy consumption and generation, and also the waste, and which is their management. So when we have all the information about all the key actors that we want to include it in the assessment, we throw big data and other assessment technologies. We provide different mapping of circular economy opportunities, and for each one we promote a strategic agenda, taking into account an action plan for each one, taking into account the viability of technology, but also the environmental, economic, and social viability and impacts that each circularity that we propose here has in the context of the territory. And also in the circular economy concept, we need to take into account the new business models, and also the governance and administrative alliance that we will need to promote to be a real impact or a real implementation about the circularity. When we have defined this strategic agenda with different plan action for its circularity, we have also to support to the regions, to the city councils or the organizers of the companies to support to implement these circular economy projects. And then to be circular in the future, we provide some monitoring circular indicators for the clients. So regarding the concept of the circular economy in the urban water cycle, from Agua de Barcelona and Swat, we are promoting the concept from the typical and conventional wastewater treatment plant to convert to a biofactory. The concept of the biofactory is to promote the three zeros, is regarding applying the circular economy concept to produce autosufficiency energy in the context of the biofactory through the biodigestation in the wastewater treatment plants to provide the autosufficiency energy for the biofactory, but also for the companies and the organizations that are maybe in close to the biofactory in an industrial area. Also, we want to promote the concept of water, of course, regarding the wastewater. The 100% of the recycling wastewater through the reclaimed water for non-potable uses, maybe for irrigation, for recharge the aquifers, or for cleaning, or for the refrigeration towers, or other non-potable uses. And finally, the other concept is the waste, to promoting the waste to landfill and to valorize and extract some nutrients from the water lines, about some chemicals, about nitrogen, phosphor, and other parameters that we can apply in the agriculture. So this is regarding the context. We are now moving to the circular economy models in Barcelona metropolitan area. I am explaining two specific case studies that we have finished, and in some of them we are continuing implementing the circularity in each region. These two municipalities are in Catalonia, in the metropolitan area, is Sant Feliu de Llobregat and Gavà. In both projects, we have implemented circular economy implementation guidelines applying in the circularity, and we have obtained from 2016 and 2017, in both case studies, a pack of circular opportunities with more than 20 circularities. The methodology is split up in three steps. We, as I mentioned before, in the methodology application, we have defined the key actors from the primary sector. We have included the agricultural and parts. That this is a specific organism that is supra-municipal, that is in contact with different municipalities. This is a very promoter of the circularity in a region, is a very good actor. Then the secondary sectors from industry, very important in both cases, to including the cross-sectorial industries in each industrial area, but also the tertiary sector, more for urban closest to the context. The natural areas in both cases, the two parks, the Collserola Park and the Garraf Park, and also, of course, the administration, the local councils and the regional, because they are very the dynamic part in the context of the project. We have included different flows, and we have identified different strategic agenda. Focusing in the case of San Feliu, this is the circular map that I mentioned before that we have constructed in the San Feliu de Llobregat. We have obtained more than 10 circular opportunities, with some safe in the context of global warming potential, in the benefit of the project, regarding the benefit of new economic activities in the project, and also some creation of new jobs, the green jobs. And one of some of these circularities you hear in this square. This is regarding the reclaimed water for non-potable uses for cleaning, for irrigation in the context of the municipality. Other taking into account more initiatives regarding the increase the self-produced energy based on the industrial sludge biomass, and promoting an agro-industrial cooperative between others, and all, of course, in the case of the organizations, the extension of the life cycle of the industrial waste. In the case of Gavà, it's a similar scenario, taking into account a circular map. We have obtained also here huge reduction of the CO2 emissions, but also the creation of new business models, taking into account the industrial area. And we have obtained different circularities more regarding the energy. We have implemented an energy agent shared by the companies to do an individualized assessment of their invoices from energy, but also promoting some local district heating through the local biomass. Regarding water, we have promoted the reclaimed wastewater from the wastewater treatment plant in Gavà for non-potable uses, for industrial, agriculture, or other urban and recreative uses in the city. But also we have defined more global strategies regarding the circular concepts that the city council need to implement in the municipality, like, for example, the circular fiscal ordinance. So we are now to move to explain some zoom about these strategic agendas, from one measure of water, one of energy, and one of waste, to promote the evolution of the reclaimed water in the municipality for non-potable uses. Regarding energy, to impulse an energetic collaborative model between the industrial companies. And regarding from waste, to find some solutions to the global life cycle to specific waste, to be recovery as subproducts or raw materials, or others, to promoting some collaborative models, including the solid waste urbans that are assimilable to the solid waste urbans from the municipality. So regarding the reuse of water for non-drinking uses, in the case of San Feliu, they provide some part of the blue infrastructure that are provided from the double reclaimed water infrastructure. And we have done the study to facilitate the wastewater treatment plant and that are in contact with the industrial area, to promote this reclaimed water for watering the public parks, or for cleaning the streets, or maybe for other non-potable uses like the administration from the fridge towers. In the case of San Feliu, in the case of Gavà, sorry, we have implemented now and water consumption analysis and estimation of the potential demand. The wastewater treatment plant is here. It's more far away than in the case of San Feliu, but we are studying the construction about some infrastructures, and also the potential demand to provide the maximum potential that the wastewater treatment plant can provide to the industrial users or other users, like, for example, the agricultural park. And then we have done also, in the context of the implementation of this opportunity, the economic viability and quality, and also the environmental point of view of this measure, taking into account the ecosystem services, and also the water quality that all the users that are potential demand needs for their uses. And also we have done different actions of communication and civilization about the water reuse. So regarding the collaborative energy model that I mentioned, first we have done the characterization of the energy consumption profile for each company that they want to participate in the project, with a safe almost 8% in the invoices of energy consumption. And we are now constructing some collaborative energy model in the huge area of the industrial area in Agua. So regarding the waste, we have implemented the individual measures that are specific for each industry. More or less 20 industries have participated in the project, and we have helped to the users to provide the best circular option about their specific waste that now are managed to landfill, but this is not the best option. And we are doing a collaborative options of industrial waste valorization, taking into account and green points, and in collaboration with the urban part of the waste, and taking into account some technical, economic, and environmental point of view to include this global management from the solid waste resources that are in the context of the municipality. So regarding some circular and sustainability indicators, like, for example, life cycle assessment, carbon and water footprint, we have included also in these cities, in these municipalities, some circular indicators like the water-wise cities, that in the case of Gavà is the first city in Spain that they obtained this distinguish, that is taking into account only for water, taking into account the water sensitivity, the data transparent, the water-wise communication, and also the regenerative water service. And also we have applied the City Blueprint Index, that this is an index provided from the KWR from Holland. But also in the context of Aqua, we have elaborated some indicator revisions about all the data and scientific articles to provide 25 circular indicators to be applied in the municipalities. Regarding water and carbon management, we have done different environmental assessment regarding different footprints to be applied in the urban water cycle, like these technologies and these tools that we have obtained from the water footprint in the case of Swat, and also from the carbon footprint in both cases, taking into account the 4 steps of the urban water cycle: the drinking water treatment plant, the drinking water distribution, the wastewater treatment plant, and also the reclaimed water. And also we have done some experimental work, but this is very important, the direct emissions from the global, from the greenhouse gas emissions. We are now doing some monitoring in the campaigns to obtain some specific factors. So regarding the life cycle thinking, if you don't know the tool of the Life Conduct, this is a free tool that is available from a result of the Life project, but also we have applying different initiatives in the context of the urban environment, but also in the urban water cycle regarding the life cycle assessment concept, the life cycle costing, the social life cycle assessment, taking into account the guidelines of the social life cycle, and also the other initiatives derived from the life cycle thinking, like the coefficiency and the water footprint. From the life cycle methods application, there are some examples that we have done from more or all the wastewater treatment plants from our company. We have obtained different eco-labelings, different eco-efficiency assessments to include the global warming potential, but also the water footprint. And regarding, we have applied the social life cycle assessment in context of the vulnerability of the different actions from my social point of view. Some conclusions to finish my presentation. So this kind of studies have a huge added value in the cities and in the organizations that apply in the context of the city council, collaboration inter area between all the departments or administrative locals in the city council, in the municipality. Some collaborations in context with other autonomic and regional entities, but also some public and private collaborations to co-create the circularity models, taking into account the digitalization, the disruption technologies, and other assessment monitoring circular opportunities. So some of these challenges are that we will need to extend this collaboration spirit to all parties involved in the water, energy, and waste governance models, not only from one part. In the context of the urban water cycle, maybe this is the promoter, but all the actors need to be part of this concept. And we need to transfer this concept for metropolitan areas to be in context and align with the circular economy plan actions from Europe. We need to collaborate in the circular economy projects between the city council, because it's a very good synergy with taking into account the companies, the consultants, and in this direction. Digital solutions are mandatory to establish these assessments and these opportunities to assess all this data and transparent data, that is open data in the municipalities. And we need to promote renewable energies to obtain the synergies between them from local solutions. And so the cities need to implement some innovative rate settings mechanisms to encourage the regions and organizations to be circular. This is all. Thank you for your attention. And if you have any question, I'm here until 11. So the floor is yours.
Thank you very much, Maria Jose. So, any question for the speaker? Don't be shy.
If not, I hear. Sorry?
Okay. In the chat, we are waiting a question.
I can see the chat now. I don't know if...
Yes, in that I make it. Okay. You mentioned some economic savings in the case of Gabans and Felu. Okay, the benefiting is, in this case, from savings, are different levels to take into account. In the case of the energy consumption, the benefit is the companies. The companies are the benefit of these savings. And in the case of the global numbers, the global KPIs that I provided, is in general, maybe it's a sum from the different benefits from the companies, or maybe from the city council, regarding for example, from energy, some savings from the organizations and the companies, because we have done the auditories about their energy invoices, but also the energy auditories about their processes, but also the city council have some benefits, because we have done the same exercise in their case. And other savings, for example, promoting in the circular economy, is that the circular economy finances. The city council asks for us, taking into account which measures they can implement as administrative local services to promote the circular economy. So they are promoting regarding the waste. If you need to pay some tax, for example, if your waste is to landfill, but if you provide some best circular option for this waste, you need a bonification in the context of the administrative tax that you need to pay. So there are different saves from water, energy, and resources, taking into account the different actors. You're welcome, Fabian.
More questions? I can see the chat.
I'm reading the chat.
Okay.
No, there are no more questions on the chat.
Okay, thank you. I have one question, if possible, Maria
Yes.
Jose. I was thinking about public administrations, and I would like to know if are public administrations generally supporting this kind of implementation of biofactories or something like that in wastewater treatment plants.
Yes. In these two cases, the city council are 100% promoted the water reclimate in their regions. It's necessary to say that in these two cities, they provide the wastewater treatment plant, and this wastewater treatment plant has a tertiary treatment to provide this reclaimed water. In the case of Gaba, we are now in the third phase. We started the project in 2017, and we are now starting the third phase, and we want to be real, this reclaimed water. And they are very conscientious and sensibilization with the reclaimed water. So they promote the reclaimed water in different sensibilization actions, and also promoting some infrastructure in the municipalities. And in the case of San Feliu, of course, it's the same, because when we constructed the infrastructure, the drinking water distribution infrastructure, they construct a double infrastructure to provide the reclaimed water in the future. So they was very visionary about the reclaimed. So sometimes the city councils are very promoted, but the problem is we have the Real Decree 1620 for the reclaimed water, but the evolution of the implementation for the different non-potable uses is not the same in one region or other city. Because, for example, in the metropolitan area of Barcelona, not are now the same non-potable uses available for San Feliu than from Gaba, and there are 30 kilometers of distance. So this is a work that we will need to construct from the public and also from private context. But to sum up, they are very consensus, and they are promoting. They are the dynamizers of this project. So they are the dynamic actor in the context of to apply the circular economy in the regions.
Can you hear me?
Yes.
Okay, thank you. I have a really high delay between. I can hear you perfectly, but the image in my computer, the program is working badly. So sorry. I don't know exactly if you can hear me very well, because I'm not. If I don't know if I'm with the microphone on or out. You can hear me, no?
Okay, but
Juan Manuel,
you're
Juan Manuel, everything is okay.
Okay,
Yeah.
thank you very much.
You can present the next the next, and after you go out and you come next.
Oh, perfect. Okay, I go into again, no? You mean when I present the next speaker?
Yes.
Okay, thank you very much. Let me introduce then the second speaker, Monse Meneses. Monse has a degree in chemical sciences and a PhD in chemical engineering by the Rovira y Virgili University of Tarragona. She is currently an associate professor in the Department of Telecommunications and System Engineering of the Universitat Autònoma de Barcelona. She has participated in many research and transfer projects at national and European level. At present, she is the main researcher of a national project within environmental sustainability in the development and application of the life cycle assessment methodology, as well as in the application of circular economy. So, Monse, thank you very much for being here, and the floor is yours.
Microphone, Monse. We don't hear you.
Hello, can you hear me now?
Okay.
Okay, now it's fine.
Okay, I'm trying to share the presentation. Can you see the presentation?
By the moment, Monse.
Okay.
Stop the chat. And I put presentation.
Okay. I think that I have
Okay, it's okay.
Hello. I don't know, but there are something that is missing in this slide. I don't know in the others. Yeah, for instance, here there is.
See,
maybe
if you want to share your screen,
Yeah.
and you
know what you're seeing, then it will do.
Okay. Okay, now?
Okay.
Thank you. First of all, I'm very glad to be here because it is a pleasure for me to present and share with you the study that has a title, Integration of Environment and Economic Aspects to Wastewater Treatment Plant Control Actions Evaluation. Thank you very much for the organization for the invitation for the International Conference on Water and Sustainability. Thank you. Large amounts of fresh water are used daily around the world, becoming wastewater. This wastewater must be treated to avoid contamination of the receiving water, rivers or lakes, which could affect aquatic life and consequently biodiversity. Due to this, wastewater treatment plants are necessary to maintain the required level of water quality. Some of the pollutants are reduced to low levels by the default wastewater treatment plant structure without applying any automatic control. However, other pollutants are more difficult to reduce. For this reason, and also to restrict operational costs, the application of control engineering in wastewater treatment plants is playing an important role in research in recent years. Specifically, maximum concentration limits are established to discharge in the receiving environment. Nitrogen and phosphorus are nutrients that can cause eutrophication in the receiving water and consequently the death of aquatic beings. Precisely, keeping total nitrogen or ammonium nitrogen concentration below the limits is usually one of the most difficult objectives to fulfill in wastewater treatment plants. In order to achieve all those targets, the application of operation strategies in wastewater treatment plants are very common. Another major issue regarding to wastewater treatment plants is the greenhouse gas emissions generated during the treatment process. Actually, greenhouse gas emissions are important in maintaining the proper temperature for life on Earth, since they retain part of the infrared radiations reflected from the surface in the air. The problem is that the greenhouse gas emissions increase generated by the industrialist world is creating a global climate change. The optimization of the wastewater treatment plant is a difficult task, as well as the achievement of the eco-efficiency targets when running a wastewater treatment plant is a complex task. Regarding the implementation of technology, solutions based on the optimization of control systems performance, the changes faced by control system design rely on the complexity of biological process, the dynamic effect of temperature, and influential variables and interactions between the different units. Moreover, the influence load exhibits fluctuations associated with human activities in the catchment or rainfall, in the case of combined sewage systems, and seasonal effects due to temperature and influent flow rates variations. These complex systems should be operated and controlled considering plant-wide effects, addressing the interaction between the different subsystems and the multi-objective nature of the problem to consider eco-efficiency targets. Wastewater treatment plants consider several units working at different time scales, primary and secondary clarifiers for physical separation, activated sludge for biological treatment, anaerobic digester, etc. The configuration of the plant with sequential units process constituting the water line, the sludge line, and the gas line. In fact, there is the orientation of the user wastewater treatment plant and operation studies where effluent quality is one of the major concerns. Due to the implementation of control, the general performance of wastewater treatment plants has been improved, but the analysis from the environmental point of view has not been detailed sufficiently. This is what drives the intention of this work, by proposing to complement the existing water quality measures in terms of pollutants with analysis of potential impacts that can be performed. This is to be accomplished by using the environmental tool for assessing the environmental performance, the Lifecycle Analysis. Lifecycle Analysis provides a wide and more complex perspective. With the introduction of this new axis, complementary view on the effect of the plant operation will prove to be useful in order to decide the most appropriate way of operating the wastewater treatment plant. So, although there is a large number of words that apply control strategies in wastewater treatment plants, the evaluation of greenhouse gas emissions and the integration with economical aspect has emerged in recent years. We can say that some steps have been made in this direction, but there is still the need to go in this direction of numerical, quantitative, integrated assessment that trades off the different aspects and evaluation criteria, effluent quality, economical cost, and greenhouse gas emissions. The idea is to show how much important is to integrate the economic and environmental aspect at the same time into the evaluation. Because of that, the objective is to analyze the behavior of some of the most typical control actions used to build up plant operation control strategies, taking into consideration all the above mentioned aspects. In this context, to introduce an integral indicator that allows a global quantitative evaluation of control strategies in wastewater treatment plants. So the objective is to define eco-efficiency targets based on the environmental and economical integration to the evaluation of wastewater treatment plant control strategies. So our assessment combines plant performance, evaluation criterion as effluent quality, operational cost defined by a Vetsmart simulation model, jointly with a detailed environmental evaluation for impact category provided by Lifecycle Analysis. The joint analysis to be conducted aims to get a clear and a clever answer regarding the choice of the appropriate control strategy. Of course, the selection will depend on the end user preference, but the fact of having both perspectives will definitely add a wider understanding and explanation for the choice of one control strategy in front of the rest of the strategies. A Vetsmart simulation model is used for evaluation of the proposed control strategies, as it is common practice in wastewater treatment plant research. The one that we are going to use is the VSM2G, which is an extension of the 2, but with the inclusion of the greenhouse gas emissions. A wastewater treatment plant is a very complex process that encompasses biological, transport, and hydraulic phenomena, among others. There is also a few considerable range of plant layouts. All those factors make it difficult to propose control and operation alternatives, and in particular complicate their evaluation and comparison. With the aim of solving this problem, the Vetsmart simulation model was developed. The Vetsmart is a simulation environment defining a plant layout, a simulation model, an influent load, a test procedures, and evaluation criteria. The first version was the best one, which includes the biological treatment and a secondary clarifier using 1 week period to evaluate results. So this Vetsmart evolution to the Vetsmart 2 that includes the whole cycle of the wastewater treatment plant, adding the sludge treatment, and apply the period of evaluation to 1 year. In this work, we have used the Vetsmart simulation plan to with the greenhouse gas emissions. This Vetsmart recognized simulation platform that describes the water and sludge line of a municipal wastewater treatment plant, as you can see in this slide. This Vetsmart simulation model includes the influent profile and the evaluation protocol. The Vetsmart simulation is designed for an influence with an average flow rate that can you see here. In the same way as in the case of the number 2, is made up a primary clarifier, a secondary clarifier, a secondary treatment, and a sludge treatment. The secondary treatment includes the biological reactor and a secondary settler. For the biological treatment, 5 reactors are considered, 5 biological reactors, 2 of which are anoxics and 3 are aerobic. The performance evaluation of the plant is done with the Vetsmart by considering the integral performance assessment of the whole plant regarding the effluent quality, the operational cost, and the greenhouse gas emissions. The effluent quality index is related to the loss of fine space due to the discharge of pollutant into the receiving water. The effluent quality index is expressed in kilograms of pollutant per day and is calculated weighting the effluent concentration of the different pollutants according to this expression. The second criteria, the economic cost for operating the Vetsmart simulation, is expressed using the operational cost index, taking into account the aeration energy, the pumping energy, the sludge pollution, the consumption of external carbon, the mixed energy, the methane production. And for us, the last criteria is the total greenhouse gas emissions production is computed according to the method proposed by the Vetsmart and include the biological treatment, the sludge treatment, the difference between electric consumption and electric generation, and the sludge to be disposed. So, in this slide, we present the control actions that we have studied. In the Vetsmart, there is a default closed-loop control strategy defined. This is used as a reference for studying the performance of alternative control strategies proposed by the users. The default is the first one. This default closed-loop control strategy consists on controlling the dissolved oxygen concentration in the 4th tank, manipulating the oxygen transfer coefficient. For this system study, here different control actions have been considered and applied individually or grouped that will allow us to evaluate their impact on the functioning of the plant in terms of the operating economical cost, the effluent quality, and the greenhouse gas emissions. The definition of those control actions starts from an inventory of the main measures, variables of interest in the plan, and the possible control variables that can be used in the influence. Then you can find here a summary of the different actions considered. The first one is the default one. Then we can find the control of the dissolved oxygen, the control of the nitrate concentration, control of nitrate concentration in the last anoxic tank. Okay, you have here a summary. The control strategies are defined by combining these control actions in order to allow the assessment of the individual actions, but also the influence between them. When we get the results for the Vetsmart simulation model, we get for all the strategy the different value of the different criteria. But we present here the result for the three criteria for all the strategies studied. An evaluation of the strategies pointed out a very large variation of the results concerning the three considered indicators. Each one of the strategies show very good results in one of the indicators, but they have a different impact on the other indicators. According to these results, it is difficult to conclude the most appropriate control strategy as provide advantage, but neither is clearly better than the other. Because of that, a more complete evaluation is therefore required in order to select the most suitable control. Thus, it results in the necessity to use a global indicator in order to obtain a more holistic view regarding the performance of the control strategies as a whole. In that circumstance, it is proposed here to use a global numerical analysis to consider the influence of the adapted strategies of all three indicators, and to see also how the introduction of the greenhouse gas emissions considered has repercussions on the performance of the control strategies. In order to achieve this, firstly, a scaling operation is performed for the three indicators to bring them to compatible values. Thus, the indicators' values are scaled with respect to the maximum value. Next, the following two indicators are defined for the evaluation of the implemented control strategies. The first one, you can see here, only takes into account the water quality and the operational cost of the plant. And the second one is also taking into account the information regarding the greenhouse gas emissions. The lambda factor serves to weight the terms included in the indicators, giving a smaller or large importance to each of them. The way the two indicators were defined is related to the fact that the main aspect in a wastewater treatment plant is the effluent quality, and the second part of the evaluation concerning the cost expressed purely in economic terms, and in the first indicator, or regarding the economical and global environmental impact, the greenhouse gas emissions, in the second indicator. At the end, the environmental impact is a cost to be paid for operating the plant. This is why in the second indicator, the lambda factors enter in the same way as the operational cost index. An evaluation of the most complex strategy pointed out a very large variation of the results concerning the three consideration indicators. Each one of the strategies show very good results in one of the indicators, but they have a different impact on the other two indicators. As it resulted in the necessity to use these global indicators in order to obtain a more holistic view regarding the performance of the control strategy as a whole. A graphical representation of how the best control strategies change depending on the adopted criteria and on the weighting factor lambda is shown here. Here you have represented the control strategy that presents the best results of the global independent, depending on the lambda value. So it's the best control strategy depending on the value of lambda. Note that the strategy 8, the one that shows the best results on water quality, is the best strategy in both indicators where lambda is close to 1. So when effluent quality has the largest share in the criteria. But if lambda approaches to 0, is in this part, the best strategies change. This time it is different in relation to the criteria 1 or the criteria 2. The advantage of using this global indicator is that they provide information in accordance to the user interest in the adopted strategies. The disadvantage is that in this way we have only one image of one of the indicators, which is defined by the selected lambda value. Because of that, a more appropriate way is to represent the evolution of the indicator in relation to the change of the lambda factor within the range. In this slide, we show you the evolution of the second indicator for the 7 best performing control strategy with respect to its minimum value. From this figure, you can notice that around the value of lambda 0.668, all the control strategy indicators change the direction. No sé si... ¿Hola? Sí? Se m'ha anat la...
La presentació.
La presentació, sí.
Tanca i torna a obrir.
Tanco tots.
Bueno, no, en l'Adobe no. Obre ara la teva presentació.
Jo la tinc...
Ara ho veiem, això.
Ara, veieu la presentació? You can see the presentation now? Yes? Okay, so I will continue. In this slide, it is show the evaluation of the second indicator for the 7 best performing control strategies with respect to the minimum value. From the figure, you can notice that around the point 0.68, all the control strategies indicators change the direction. This is due to the fact that in this point there is a switch between the best strategy according to the second indicator. All the same time, the shape of the curve evolution is related to the fact that the best strategy according to the quality strategy 8, you can see it in green color, give the worst results according to the greenhouse gas emissions. And the best strategy according to the greenhouse gas emission, the number 12, give the worst results according to the Effluent Quality Index. Also, for this figure, it can be seen that there are strategies like the number 9 and the number 10, which although suboptimal for all values of the lambda factors, offer a good performance of the second indicator index for a wide range of lambda, being difficult to assess the global performance of these strategies. This fact leads to the idea of using a global criterion to quantify the full area between the evolution curve of an indicator in relation to the lambda factor corresponding to a strategium and the minimum value of the indicator, as you can see here. Thus, by using this global indicator for each one of the 2 indicators that we have defined for all the contract strategies implemented, the obtained results is present here. For this graph, it can be seen that there are 3 strategies, the number 9, the number 10, and the number 12, leading to very good results in both of the considered performance criteria. They show up the idea that from all the implemented control actions, thus based on the control of nitrate and in the second anoxic tanks using internal recirculation, flow rates, and control of the suspended solid concentration, offer the best compromise on the 3 elements considered for performance the evaluation of wastewater treatment plant, the water quality, the operational cost, and the greenhouse gas emissions. However, according to the results, it is difficult to conclude the most appropriate control strategy between the number 12, the number 10, and the number 9. So, a more complex evaluation is therefore required in order to select the most suitable control strategy. In the next section, the goal is to complement the discussion by introducing the lifecycle analysis results in order to get a more complete overall view of the plant operation. So, because of that, the objective of this research is to evaluate the environmental plant performance under different scenarios and to compare those in order to select the most strategy based on the multiple evaluation criteria. It means to consider in the control strategy the criteria that the Vetsmart will proportional and the indicators for the life cycle analysis. The philosophy used in the life cycle methodology is the concept of life cycle thinking. Life cycle thinking means the environmental attention is expanded from the specific production site to the whole product life cycle, including the supply chains. Life cycle analysis is a technique to assess the potential impact associated with a product or process during the whole of its life cycles, and involves the following steps: the definition of the goal and scope, the inventory analysis, and the impact assessment. How we are going to do this kind of evaluation? We are going to evaluate all the steps of the production and how you get the material, how you produce the material used, and the product, how the product is used, how is the distribution realized, and how is the final life of the product. For each one of these steps, we are going to evaluate all the inputs and outputs, and then we will have the inventory of the product. One of the crucial points of the lifecycle analysis application is the appropriate inventory definition. The inventory phase for the core of the lifecycle analysis and is the most time-consuming part. After that, we will evaluate the different environmental impact of as the global warming or the acidification. The main objective of this lifecycle analysis study is to analyze the environmental profile of the control strategies implemented in the Vetsmart simulation in order to compare that by also introducing the environmental perspective. A key point in the lifecycle analysis is to define the product units, the functional unit. Here, the functional unit, it was 1 meter cubic of wastewater treated. The system limits, the system boundary have been considered the operational phase, and we have excluded the construction of the wastewater treatment plant, the sewer system, and the transportation of wastewater. The construction phase has been excluded from the system boundary because the plant usage is the same for all the control strategies studied. The slag for production is contemplated here for use in agriculture as fertilizer. And the data, most of the data were collected from the dynamic simulation performance using the Vetsmart simulation. However, some other parts of the inventory data not provided by the simulations were collected from databases and literature. In this slide, we present the results of the lifecycle analysis for 70 studies and for 4 strategies. As the main results, lifecycle analysis provides an assessment of the environmental impact for each control strategies according to the established impact categories. It can be observed that the addition of the control of the total suspended solids in the large aerobic tanks by manipulating waste stage flow rate and the control of the nitrate concentration in the strategy number 12, reduce the environmental impact. These strategies present the lowest impact in all impact categories except in eutrophication. Because of the scale of the numerical value of seeds, it may be difficult to appreciate difference and compare them. Therefore, it is shown in parentheses the relationship of each assessment with reference to the best one. Out of all the implement control actions, thus based on the control of nitrates in the second anoxic task using internal recirculation flow rate and control of the suspended soils concentration in the fifth tank using wet waste, offer the best compromise on the three elements considered in the evaluation. We see in this section how taking into consideration the life cycle analysis results will allow one to go one step further and to refine such categorization and to choose the best available option from the environmental point of view. With the life cycle analysis methodology, we are able to add extra criteria for complementing the evaluation provided by the Vetsmart simulation model, and this perspective provides decision makers with an additional dimension for choosing the best control strategy to apply. Taking into account a summary of the best results, the strategy number 12 can be selected as the most appropriate control strategy for implementation because it has been the best score in one of the three criteria from the Vetsmart and in 6 of the 7 criteria from the life cycle analysis. So this research presents the effect of the main control actions used in wastewater treatment plants regarding the 3 usual indicators used for performing evaluation: water quality, operational costs, and greenhouse gas emissions, and also propose an integral indicator for performance evaluation able to take into account all aspects mentioned on the plan assessment. The reported results emphasize the importance and useful of using multiple evaluation criteria to compare and evaluate control strategies in a wastewater treatment plant for more informed operational decision making. Multiple evaluation criteria of wastewater treatment plant control strategies include an additional dimension within the evaluation procedure. Because of this, it can be concluded that consideration of life cycle analysis criteria provides an additional criterion allowing for better environmental evaluation of control strategies in wastewater treatment plant. Thank you very much for your attention. If you have any question, it would be a pleasure to answer you.
Okay, thank you very much for your kind presentation. Any question? Yes, I can see in the chat that there are. Is this the only question? Okay. In the chat, there is a question: is the 30 or 40% of carbon footprint is provided by direct emissions, and the other percentage from 20% energy, 20-30% sludge waste management, and 10% chemicals? The first question is, which is the best criteria of simulation model that you have applied in your model? And the second one is have you developed any tool for that? Or maybe which simulation you use?
For our experience, it is right. The percentage that Maria Jose say about the carbon footprint is true. In a conventional wastewater treatment plant, the 30 or 40 of carbon footprint is provided by direct emission, and the other percentage from 20% energy and 20 or 30 slash waste management. I agree completely with this percentage. The Vetsmart simulation, we have not developed this Vetsmart simulation. This Vetsmart simulation is the simulation model that is used in wastewater treatment plant control for evaluate control strategies. And what is the best criteria of simulation model? Best criteria of simulation model that you have applied in your model. Okay.
I can explain more.
Yeah, we have used the simulation model, and then as the result that we get, it were not enough to achieve a good conclusion, then we have developed the global integration indicators. See? I don't know if I have explained it. So we used the criteria provided by the Vetsmart simulation, and then as we see that we couldn't arrive to a good conclusion or a global conclusion, we developed the global indicators. With these indicators, we have considered all the ones provided by the Vetsmart simulation, and then we have be able to arrive to our conclusions about our control strategies.
Okay. Maria Jose
Maria, you
is...
want to say something? Maria Jose?
No,
No, it's okay. We can talk with Montse more about the best simulation. My question was regarding the which criteria, if we increase the quality parameters, we decrease other parameters. So this is the idea, but we can explain in private if you want. And the other question is regarding you have developed any tool that, or maybe you use any simulation tool or any commercial tool.
Any tool. We use a tool that has been already developed by a Sweden university.
okay. I have one question for you, Monse. It's regarding the life cycle assessment. I was wondering if maybe you don't have this information now, but which part of the wastewater treatment plant present typically the highest carbon footprint? I can hear you. Now.
Yeah, the part of the wastewater treatment plant with the highest carbon footprint is always the one with the highest energy consumption. Mm-hmm. Especially the aerobic. Because of that, we always recommend to promote the reduction of energy consumption, the use of more renewable forms of energy, but from a point of view, this objective is not only for the wastewater treatment plant. It should be always in our daily life to promote the renewable forms of energy and to reduce the energy always.
Okay, thank you. And I suppose if to implement a solution in a wastewater treatment plant, and the operational criteria is no I think that it should be or it must be complicated to choose between operational criteria and environmental criteria, because I suppose that not always are in the same direction. Have you think about it? How to choose between operational criteria or environmental criteria?
This is a difficult question always, because you always have the most expensive option is the one with the lower environmental impact. So you have to spend money to be able to reduce your environmental impact. From some years ago, always the economical criteria, it was the only one that was considered in all the decisions. Nowadays, I want to think that the techniques and the politics, they are considering also the environmental aspect. But the reality is that the person that has to take the decision always has a difficult position, because usually they are opposite. So you want to get a best environmental situation, you should to spend money and to increase your cost. And I think that this is the responsibility sometimes of the government, that they need to help to the industry in order to invest, to spend money in the reduction of the, or to decrease the environmental impact. But I think that when you are a private enterprise, if the government don't help you, it is very difficult.
Okay, thank you very much, Monse. So, Maria Jose, thank you. I have seen that you answered my question in the chat also. So, if there is no more questions, I think that we are going to our last two speakers from Italy, Adriana Del Borghi and Michela Gallo. I hope my pronunciation is correct. I'm not sure. Michela and Adriana, sorry for that. Dr. Adriana Del Borghi is the Prorector of Sustainability for the University of Genoa and Director of the Center for the Development of Product Sustainability. She's Associate Professor in Chemical Engineering at the University of Genoa, Delegate for International Climate Negotiation at the United Conference of Parties, and member of the Italian Commission of Environmental Impact Assessment and Strategic Environmental Assessment. Among others, Adriana is a member of the editorial board of international journals and author of the impressive amount of more than 150 scientific papers. And Dr. Michaela Gallo is member of the scientific committee of the Center for the Development of Product Sustainability. She's associate professor in the environmental engineering, professor of polluted sites remediation and solid waste management, and mitigation and adaptation to climate change at the University of Genoa. She's delegate at the United Nations Conference of Parties and member of several international boards. Her current research activities are related to life cycle assessment, circular economy, eco-design, greenhouse gases emission reduction projects, carbon capture, and storage. So Adriana and Michela, welcome to the Congress, and thank you very much for being here. And the floor is yours.
Thank you very much for the invitation and for having the opportunity of being here with you, just to share our research on water and water sustainability at the University of Genoa. Due to time constraint and to save time, we decided that I can perform the presentation, and then we are both available for questions and for curiosity on the research. So if you agree on that, I can share my screen. Okay, thanks a lot. I'll try to share desktop. Please confirm me that it's working.
Yes.
Okay, and that the slides are moving, right?
Perfect.
Okay, thanks a lot. So today, well, we take the opportunity of discussing about our last research on water scarcity performed within the agri-food supply chain. This is a long research that we are performing through different body of the University of Genoa. We work together, Michele and me, within the Inter-University Center of Product Sustainability, which is a center focused mainly on circular economy, industrial symbiosis, product sustainability from a research point of view. And then, we found that later a consulting company, which is called TETIS, which is Techniques for the Impact on Sustainability, which is just focused on the transfer of knowledge and technology towards just to have a better options to help company with specific tools in order to use the finding of the research. So now at the University of Genoa, concerning product sustainability and concerning life cycle assessment issues, we have several options of helping company in order to understand issues concerning the life cycle of process, circular economy, and products. So after this brief introduction of our research center, I would like to go ahead towards the purpose of the research. A couple of days ago was the water scarcity day, so it's clear that this is one of the main issues that, together with climate change and climate emergency, had to be considered with practical and with very high attention from every actors involved in this context. So this is the main aim of this research that we started in 2010. We start to work with a company, with a group which is active in Italy, but in Spain as well, which is Conserve Italia, which has also a brand which is Conserve Spain, which is one of the largest agri-food European companies producing vegetables and preserved vegetables, which is interested in better understanding its supply chain, and to understand the best way to reduce along the supply chain, along the life cycle, considering the overall impact of their products, starting from the agriculture phase, as well their impact on the environment. So the purpose of this research and this presentation as well is to understand how to calculate through a life cycle assessment so through a robust method the impact of a company, but just having just understanding how to understand in order to make them really directly applicable by the company in order to define a unique indicator in order to help decision makers at the high level of the company to make decision considering all the impact. That's why we'll decided to try to define a unique indicator within the context of the water, energy, food nexus, as we think this can be considered one of the best options to to measure the impact on sustainability for the food industry. As known, there are several methods in which water scarcity and water stress is measured at international level. There are many indices that which are developed and which can help us to measure water use, water supply, and water scarcity. But it's not very easy for companies to understand which method is the best one, and how to make the interpretation of indices, which are very difficult to be understood also for scientists and for researchers working on that field. Just to make a brief recap on existing indices, starting from the last 20 years, several water scarcity indexes has been developed, starting from indexes based on human water requirements, just starting from the human need towards water resource vulnerabilities, so just moving to the ecosystem, and then indexes incorporating environmental water requirement and also the condition of ecosystem maintaining sustainable levels of water availability. So just we can say, and we can see that the definition of indexes concerning water follows the same rationale of sustainability definition. So starting from human needs to a more comprehensive, sustainable point of view. In order to measure these indexes, the most known is the measurement of the virtual water content, which can be based, of course, on such life cycle assessments studies, in order to understand that we can just see just a very small part of the water impact of food products, if we do not consider all the hidden impact of the supply chain. Of course, if we consider beef, we'll have to consider also the livestock impact, and of course all the aspects which are not really that's of course not so clear if you do not consider the whole life cycle of a product. So it's clear that virtual water is the water embodied in the production of food products. We prefer to use a life cycle approach, including and assessing the virtual water content, but using water and this ISO standard approach, which is include water footprint assessment within a life cycle assessment framework. So our research are based on ISO 4046 in order to use an international recognized framework for our research. And this is just one of the last review on water indexes available. So it's clear that there's a lot of scientific debate on how to measure and how to communicate, how to use water index addressing water use. So it's clear that we are pretty far from having just a unique, a specific unique indexes that can be used by companies, and in order to have just a tool to make decision based on that indexes. So that's why we try to understand how to weight and to normalize standard greenhouse gas life cycle assessment results in order to assess just a unique indicator based on the water energy food nexus concept, in order to understand that all of these four, as we consider food as well, indicators are connected, as of course we cannot focus just on water availability and water stress indexes, as Of course, for example, if we consider that water can be produced, for example, through seawater desalination, so it's clear that this process can solve the problem of basin of water scarcity in basin and in lake, but it's clear that seawater desalination has a very high energy consumption within this process. So it's clear that and related to the energy consumption will have, of course, greenhouse gas emissions. So we'll have to balance these three indicators in order to understand all the interconnection within these indicators and this impact as well. So that's why we decided to perform this research and this study in order to define a unique indicator to help companies to define industrial strategies for reducing their water footprint, but their impact within a comprehensive way. And again, we decided to follow the pathway towards the WEF indicator. So we performed a life cycle assessment according to ISO 44, and we assessed water scarcity according to the ISO 1446, and we focused basically on 5 crops considered strategic for the companies, both for volume produced, for volume which are sold by the company, but as well as they're strategic from water consumption and water scarcity issues. This is the geographic area that has been considered and has been included in the study. So we'll have the Italian territory, but in Spain as well presents many cultivation area that can be used as land use, as well as we have to consider land use within every indicator, which are particularly suited for vegetables. So we performed a study considering both northern Italy, central Italy, and southern Italy. Of course, as the extension of our territory is within north to south, we have very different climatic area, in particular from north to south Italy. So we'll have in Apulia, we have specific situation of not just desertification, but water scarcity is very high in south of Italy. So that's why we'll have different geographic area, and we developed specific indicators considering this 3 geographic area. After selecting the crops, we decided to perform a SWOT analysis in order to understand which can be the strengths, weakness, opportunities, and threats for each crops, considering their water need, the opportunities and feasibility of management improvements, and how they were strategic for the company. And after this analysis, well, we decided to focus our research on beans, on tomato, and of sweet corn for different reasons. For example, beans resulted in being the most water demanding crop per mass unit, but tomato, due to the high production rate within the company, resulted in being the most water demanding crop in terms of overall agricultural production, in order to the production rate and overall production strategies of the company. As well, sweet corn has a very high specific water consumption due to need for its calculation, for its cultivation, and for the overall production. So we decided to focus on these three crops. As said, well, we considered 3 geographic area. We involved 115 farms almost 2,000 hectares, and we performed a 2 years campaign collecting data specifically for each crops and focusing on their different irrigation system, gravity, including flooding, lateral infiltration, sprinklers. We collect several data on hose reel or pivot irrigation, while we considered drip irrigation. All this research is included within a more comprehensive research performed together with other university in Italy, in particular the University of Milan, which is performing now research on precision agriculture in order to understand how to consider specific requirements of the plant in order to give the nutrients and the water to the plant exactly in the moment in which they need that. So they are mainly agronomists, and we are working together in order to understand the best way and the best overall footprint in order to select different and to optimize specific irrigation system and agricultural techniques in order to optimize the overall footprint of the crops. We perform within the boundaries we've seen before. We perform a full life cycle assessment, so we considered all the life cycle. We arrived till the end of life of the finished products, including also packaging, distribution, and use of products. But now this research is mainly focused on the cultivation phase. So we considered irrigation, of course. So we considered cultivation. We considered diesel consumption of course, for the cultivation phase, for all the phases due to the need for the cultivation of each, specific for each crops. So we consider specific energy consumption of each irrigation option, and we consider all the greenhouse gas emission due to fertilization. So it's a quite wide work performed on the company specifically for these crops. So we performed a wide work, but now the focus was mainly to collect data and to define and to find a way to define a specific, just one indicator. So we make a decision and we select 4 life cycle assessment indicators, impact categories, in order to understand how to normalize and to weight them in order to have a unique WEF nexus. So we consider global warming potential, water scarcity measured through the AOER methods, cumulative energy demand, and of course the yield, as the water energy footprint is the water energy food nexus is related to food. So the goal of the nexus is to produce food. So we have to produce food. That's why the yield has been considered one of the main results that have to be optimized. So we have to optimize the impact of, and we have to optimize the yield as well. Here you'll find the baseline results of the 2 years campaign, specifically for each crops and for each single indicators. Based on this baseline, that which represent the weighted averages indicators for all the system boundaries described before. So we considered the weighted average results for each specific irrigation system and geographical area, and this was used to define a way to calculate the unique WF indicator. I do not want to bother you just with the details of indicators development, but we considered a normalization option and weighted options in order to normalize the results specific results to the baseline, which was calculated by through the data collections and presented in the table of the slides already seen. And with think about different options, different weighting options. For example, we thought about 5 options. For example, option 1, set the same weight for each indicator. You can see you have 25% of weighting factors for each indicators. So weighting the same, we consider that all the indicators are important in the same way. The other options focused on different weighting options. For example, option 2 set the same weight for each environmental indication, but set 0 for the yield. This is an options. While option 3 include 50% environmental indicator, 50% for yield, while option 4 and 5 consider a weight set by the product environmental footprint category rules guidance. So in the framework of the product environmental footprint at European level, which suggests specific weight for environmental indicators. So in the next slide, we will find that option 5 was considered the best options in order to understand, to weight. Of course, as this indicator has to be seen by the company point of view, we have to take a weight to the yield, as they would like to produce food, of course, but we'll have to consider as well the environmental impact. And within this 50% set for environmental indicators, the single specific weight has been set using the weight of PET/CR guidance. Here you'll find specific example of our results. For example, we'll see how this radar graph, how the results are different, and we can have different interpretation of results if we consider single indicators or we consider the average. For example, seeing the northern Italy gravity, it has a high global warming potential impact, and while the sprinkler has a high water scarcity impact. So we'll have different decisions to be taken that have to be taken considering specific indicators. So the several options, and I said option 5 will consider it as the best options. It was these results were used to define the best options and the best management practice to be proposed to the company. We performed the several graph for each crop, for each selected crops, and later we compare these results to in a circular economy, in particular in the eco-design proposal. We'll try to understand whether the company is working in an optimized way or whether they can do some improvement. For example, switching different irrigation techniques in different geographical area. For example, tomato. The pivot system can be used for tomato, that as tomato needs specific irrigation, just with the precision agriculture techniques in order to optimize the consumption of water. So we compare different irrigation techniques, and just focusing on the score, will have an improvement in the score. Please note that this has been set not as an impact but as a score. So best results can be seen for we have a higher score, we'll have a best environmental performance, a better environmental performance. So, for example, for tomato, if compared to hose reel, the drip hose, so the specific irrigation system shown by the picture was considered just for 2.3%, but it was has not only a theoretical water saving of 16%, but also an overall WEF score of slight improvement, but an improvement as well. The same calculation has been performed for beans, and the pivot irrigation allows theoretical water saving on 12%, and also a significant improvement in WEF performance, with a single score increasing of more than 15%. So just moving all the irrigation techniques using pivot can help to improve the performance of the overall companies. Of the same ways, the pivot irrigation, which is just an example of how we interpret the results obtained by the study, allows a theoretical water saving of 12%, and will have the same score, considering option 5 for just as an increasing in performance for the company. So, well, make just this quick presentation in order to understand what we're doing at the moment as a research in a public private research studies, in order to allow that for a comprehensive way we can help company to understand the best way in which they can use research result really as a decision tools and planning corporate strategies towards their product sustainability. So here we'll find our contact, and I'd like to thank you for your attention. I don't know how to. Okay. I'd like to thank you for the attention.
Okay, thank you, Adriana, for your really interesting presentation. Your study, in my opinion, is totally necessary, even more in the European countries, well, Mediterranean European countries. And I don't know if there is any question. No? No question? So then I have one question here for you and for Michela. I was wondering, in your opinion, what could be the best way to reduce the water footprint of the vegetable supply chain in Italy? And I would like to know if the measures of, if we control this, or we implement practices in Italy to reduce the water footprint, do you think that these practices can be applied in the same way in other European, Mediterranean countries?
Yeah,
I don't know if,
I don't know. I start. Perhaps Michela can add any consideration if she wants. Yes, absolutely. I guess that we lose a lot of water. We have a lot of loss of water, and our irrigation techniques are at the moment not so, of course, for cost problems, they're not so optimized within a company. So I guess that precision agriculture and moving towards giving the plant exactly the water they need can be just a way to understand to set it, to minimize the water consumption. Of course, as for example tomato, which are cultivated also in Africa. In Israel, has developed a very specific micro irrigation specifically for in order to cultivate tomatoes. So I guess that in the Mediterranean countries has similar climatic conditions, and also the water availability is similar. So I guess that we'll have to define a specific geographical area in order to set the rules to choose the right way for the just in order to choose quite in a mandatory way to use the right irrigation techniques in order not to lose water in a stupid way. Sorry for the term.
Just adding some further information. Two main aspects can influence, of course, the main results. I agree with Adriana. The main results we have found are more or less similar for all the Mediterranean area, but another important aspect to be considered that can or may differ from countries to any other country is the energy mix, for example. So in case you have the same condition from a climatic point of view, but you have a very different energy mix production, these results cannot be applied in the same way, of course. And this is an important aspect to be considered. So not only the climatic aspect, but also the energy production that may influence the final results.
Okay, thank you very much. Yes, because I was thinking during your presentation that other critical aspect is maybe this weighting index you have used, because I suppose that if you are evaluating tomatoes in other places in the world, this weighting index should be changed. I mean, no?
Yes, absolutely. It's a right consideration. We'll have to understand their weighting factors were set specifically for not just for this company, but for sure for Mediterranean area and for our specific climatic condition. Of course, for countries in which water scarcity is basically one of the main aspects to be considered, if whether we would like to produce such food as well. We'll have to understand how to solve the problem of water availability without increasing, of course, greenhouse gases and water scarcity as well. So we'll have, of course, to balance these three aspects, while perhaps some crops cannot be cultivated everywhere in the world. We'll have to make decisions also from a political point of view, as it's different to weigh every situation. But of course we can understand. For example, now we are thinking about writing down a paper on that, and in order to improve the water scarcity indicators index, of course, how to apply them to different geographic conditions can be absolutely one of the aspects that have to be considered within the paper, of course.
Okay, just to complete the information, another important aspect to be considered is the yield of crops. So, for example, in case you have a similar condition from a climatic point of view, or also a similar energy mix, but you have a very different yield of crops. So, for example, this type of approach can return different results in case you use the same parameters, but in Canada or in the Mediterranean area, because you have a very different yield of crops in this case.
Yes, I suppose that in this kind of analysis, all the hypotheses you make should be clearly explained and changed depending on the places you are studying. So thank you very much for your presentation and for your answers, your interesting answers. I don't know if maybe we have time. We are out of time. Maybe only for one question, one last question. I don't know if someone want to make a question. No? Okay, so it's time to finish this round table. We have a break now until 12 o'clock. So thank you very much to all of you for joining us. Thank you very much for all the speakers, and enjoy the rest of the Congress.
Thanks a lot. Thank you very much again.
Thank you. Bye.
Bye.
Thank you all the speakers. Thank you for your fantastic presentation, and I hope see you soon, and maybe in another context. And we move to the break, 15-minute break. And thank you, Juan Manuel, for your presentation also.
You're welcome.
See you soon.
Bye.
Bye-bye.